Assalamu alaikum wa rahmatullahi wa barakatuh. All my students of class 8th, I hope you all are doing well. Let's revise what we had done in the last lecture. I told you about the atomic number. What is atomic number? That is the number of protons present in the nucleus of an atom, of an element, and it is denoted by the symbol Z, or the number of protons are equal to the number of electrons. So Z gives us the idea about the number of protons or the number of electrons present in the nucleus, electrons present around the nucleus of an atom, and protons present inside the nucleus of an atom. For example, I told you that if Z is equal to 11, that means atomic number is 11, and the number of protons is also 11, and number of electrons is also 11. Is it clear? Then coming to the mass number, then the mass number, it gives the idea about the total number of protons and neutrons present in the nucleus of an atom, of an element, and it is denoted by the letter A. Is it clear? So A is equal to the number of protons plus the number of neutrons. So if you represent, how will you represent a particular element? Any element X, that is the symbol X, is denoted by A and Z as the superscript A, that is the atomic number. This is the atomic mass number, and this is the mass number A, that is the superscript on one corner, upper corner, and the atomic number Z on the lower corner. For instance, I had given you an example of sodium. If you have to write sodium, how will you represent it? It is represented as sodium 11 and 23 as given over here. Similarly, any other element, if you write helium, helium is an element. If you write a helium, He, this is the mass number and this is the atomic number. Or you take carbon, carbon C, this is the mass number and this is the atomic number. This is how you represent an element when you have to give the idea about the atomic number and the mass number. Is it clear? In order to find out the number of neutrons, what do? We subtract Z from A, that is A minus Z, that is mass number minus the atomic number. Mass number is the total number of nucleons, that is the number of protons plus the number of neutrons, and atomic number is, of course, it gives the idea about the number of protons or the number of electrons. So you can easily find out the number of neutrons by this formula. Then the atomic mass. How do we calculate the mass of a single atom? It is practically possible to do so. Is there any weighing balance for measuring the mass of a single atom? Now we have the answer to this. That is, imagine we have two objects A and B, and object A weighs around 12 kilograms, but we do not know the weight of object B, and that is what we need to find. And now how to find it out? We just have a weighing balance. Let's put them either side of the balance and see what happens. We can see that object A is heavier. Now if you want to find the weight of B, we will need something smaller to compare it to. So let's say we cut object A into 6 equal pieces, and now we compare the weight of object B with one piece. We see that this piece is still heavier than the object B. This probably tells us that we need a smaller piece for comparison. So let's assume we cut object A now into 12 equal pieces, which means each piece weighs 1 kilogram. And now we place them either side of the balance. We see that it's in equilibrium, that is, both the sides are equal. Now we can tell the weight of the object B. Yes, Each piece of object A here is 1 kilogram, and hence we can say that object B also weighs 1 kilogram. Is it right? Now let's ask one more question, that can we say that the mass of object B is 1/12 that of object A? That's correct. This is exactly how we estimate the atomic mass of an atom. Since we cannot directly measure the mass of each atom individually, so we measure it with respect to carbon 12. We take C12 as the standard. What is C12? What does it mean? The element carbon has many isotopes. I have told you the atoms of an element that have the same atomic number but different mass numbers are called isotopes. We need to understand there are different forms of the same element. So in the case of carbon, we will still have slight differences in the atoms, which is what makes them isotopes. So carbon 12 is one such isotope found almost everywhere in nature. You have the pencil lead, you have diamond, all are C12. So it is considered to be a standard unit, and atomic mass is thus calculated with respect to one atomic unit. And how do we define one atomic unit now? One atomic unit equals to 1/12 of the mass of a carbon 12 atom. Is that clear? So let us assume this is one atom of carbon 12. We divide this in 12 exact equal pieces. We take one piece from this out of the complete unit. Can we say the mass of the single piece is one atomic mass unit? Absolutely right. And this is used as a standard to calculate the atomic mass of any other atom. So some example of this would include atomic mass unit of hydrogen being 1, carbon being 12, nitrogen being 14, oxygen being 16, and so on. How do we understand this in a simple way now? Let me ask you a question. How do you measure the mass of a person? Using kilograms, right? We say this person mass is 50 kilograms. Similarly, we say that the atomic mass of oxygen is 16 atomic mass unit or 16 AMU. This is how we measure the atomic mass of any atom. The units used are atomic mass units. But do we know what exactly gives the atom its mass? I mean, what exactly is responsible for giving a tiny atom? Then we have discussed atomic number and atomic mass. Let's come to the isobars and isotopes. That is, atomic number gives you the idea about number of protons present in an atom, and atomic mass gives you the idea about number of protons and neutrons present in an atom. Right? You have studied this. Now, what should you consider? That is, what is the chemical symbol? That is atomic number. It is written bottom left. We have already discussed this. So this is how we represent a chemical symbol of carbon 12. Atomic that gives you the mass number 12 and atomic number 6. It can be written on both the side or either side. Similarly for chlorine also 35 and 17. Is it clear? So similarly for the other elements that I have told. So we can represent chlorine in two forms, that is, it can be 37 and 17 or 35 and 17, and the difference in the mass number is because of the presence of the or difference in the number of neutron. That is, in chlorine having a mass number of 35, there are 18 neutrons, and in chlorine having mass number of 37, there are 20 neutrons. So the difference that comes in the mass numbers is because of the difference in the number of neutrons. So atoms of the same element having the same number of proton but different number of neutrons are isotopes, or the atoms of an element that have the same atomic number but different mass numbers are called isotopes. Is it clear? So this is what is represented in the atomic structure of chlorine, that is, the difference can be seen in the number of neutrons that are present in the nucleus of chlorine atom. So atoms of the same element having the same number of proton but different number of neutrons. So this you can also observe in the case of carbon as well, whether protons are 6 in all the three, and there are 3 isotopes of carbon: carbon 12, carbon 13, carbon 14. and there are 6 neutrons, 7 neutrons and 8 neutrons. So atoms of two different elements can have same atomic mass also, but the atomic number can be different. For example, sulfur and potassium, then calcium, chlorine and argon. So these are what basically the isobars, the atoms of different elements having different atomic number but same mass numbers are called isobars. So total number of nucleons are protons plus neutrons, which give us the atomic mass. So that is how it is given over here. That is sulfur 16 proton and 24 neutron, potassium 19 proton and 21 neutron. So similarly for calcium, chlorine and argon also the number of protons and neutrons are given. So we can easily calculate the atomic mass in all the cases. You can see atomic mass is 40 and 40 in sulfur and potassium, and whereas in calcium, chlorine and argon it is 40 also. So atoms of different elements with same atomic mass are called isobars. So it's a Greek word, and iso means same and baros means weight. I think you have understood the atomic number, mass number, isotopes and isobars along with the atomic mass. Now let's discuss the exercise on page number 50. Tick the correct options. Exercise A. Which of the following is not explained by the modern model of an atom? A. Electrons, protons and neutrons are subatomic particles of an atom. Nucleus is positively charged and it contains protons and neutrons. Electrons revolve around the nucleus in fixed circular orbits. Shell nearest to the nucleus has maximum energy. So all the three A, B, C will explain by the modern model of an atom, while the shell nearest to the nucleus has minimum energy. So this has not been explained, or this is wrongly given. So this is wrong. Is it clear? D1. And 2. Electron neither lose nor gain energy while revolving in an orbit. As a result, it is strongly attracted towards nucleus and fall into it. It comes closer to the nucleus. It does not fall into the nucleus, or it takes a spiral path. It does not fall into the nucleus, that is C is right. Is that clear? Then the mass number of an atom is equal to the number of, yes, protons and neutrons. Is it clear? It is the protons and neutrons. Then the atomic number and mass number of chlorine are, atomic number here is 17 and mass number is 35. Which of the following pairs represents isotopes? It is chlorine 12 and 6, 35 and 17, or hydrogen and carbon and hydrogen 1 1 and 2 1, or argon, that is the third one, C, in which the two isotopes of hydrogen are given. This one. Is it clear? Now complete the following table. Atomic number of hydrogen 1 1, mass number is 1 2 and 1. Number of protons here will be, yes, it will be 1. It will be 1 over here. Number of electrons will also be 1 and neutron is 0. It is right. Then 1 2 1 1. Then the third isotope is having an atomic number of 1 and mass number 3. Number of proton is 1. Electron will also be 1 only, and the difference is only on the basis of the number of neutrons, that is 3. Is it right? That is 3. Then carbon, the atomic number 6, mass number is, yes, the number of protons has been given and the number of neutrons are given, so you can easily calculate the mass number, that is adding up the number of protons and neutrons, that is 6 plus 6, it is 12. This is 12. Then next is the number of electrons will be the same as the number of protons, that is also 6. This is 6. Then the second one, that is the atomic number, is 6 again, mass number is 13, and the protons will be 6, electrons will be 6, and so you can easily find out the atomic number by seeing the number of protons, that is 6. Is it clear? Then the number of neutrons will be different because it is an isotope. That comes out to be 7 now. This comes to be 7. Next is atomic number 6. Then where the number of neutrons are 8, that means the number of protons plus the number of neutron, the mass number will change and it will become 14. Is it clear? Protons and electron will be the same, that is 6 and 6 again over here. Next is chlorine, 17, 35 is the mass number. The protons will be the same as the atomic number, that is 17. You can write it clearly. Then the number of electrons will be the same as the number of protons, that is also 17 only, and the number of neutrons you can easily find 30, that is you will subtract the atomic number, that is 17, from the mass number 35, that will come out to be 18. So it will be 18 over here. The number of neutrons that will be there will be 18. Then again the atomic number will be the same, 17 only. The mass number has changed from 35 to 37. This is 17, this is 37. The number of protons and electrons will be 17. This will also be 17 again, and the change will be in the number of neutron, that is it is 20. So these are this is the table showing the isotopes of hydrogen, carbon and chlorine, where the atomic number of hydrogen will be 1 in all the 3 cases, of carbon will be 6 in all the cases, and chlorine it will be 17 in both the cases. For mass number it is 1, 2 and 3 in hydrogen. For carbon it will be 12, 13, 14. Chlorine it is already given as 35 and 37. So you can easily calculate the number of protons, electrons and neutrons. I have already discussed about the modern model of an atom, that is according to the Bohr's model, in which I have already told you that the nucleus is the positively charged center present in the atom, which is because of the presence of protons, as the neutrons are neutral. So the overall charge that is present is positive on the in the nucleus. I told you the electrons move in they revolve around the nucleus in shells which are known as orbits, and these orbits, as you start moving away from the nucleus, the electrons that are contained in them, the energy keeps on increasing. That is the shell number 1 is considered as K shell, then shell number 2 n is equal to 2 is L shell, then n is equal to 3m, and so on. So this shell number 1 is having minimum energy and shell number n has the maximum energy. So so this is what when we write the position or how the electrons are arranged around the nucleus, it is according to the different rules that we follow. So the distribution of electron in different energy levels or shells in the order of increasing energy around the nucleus of an atom is called the electronic configuration. So this is what we will study today. I will just start it today and then proceed with it in the next lecture. So what is electronic configuration? I have told you that electrons revolve around the nucleus in these energy level or orbits, and they have different energy, and how they are arranged, that is how they are distributed around the nucleus in the various shell, that is determined by the electronic configuration. So electronic configuration, or over here it is electron configuration. So it is the distribution or the way in which electrons are arranged into various orbits or battles around the nuclei of atoms. That is known as the electronic configuration. And we follow 3 rules or principle that tell us how electrons can be arranged in an atom's orbits, energy levels. Is it clear? So we'll discuss in detail all of this in the next session, inshallah. Allah Hafiz.